Hey guys, this is question MM036 of the Maths Methods Sharpen Study Guide. How to find the points of intersection between a linear graph and a quadratic graph. So, firstly we've got our two graphs, y equals 2ax squared and y equals 3mx plus b. And we want to find out there will be no points of intersection for all values of a, b, and m such that. So we've got a bunch of, terms here. And restrictions on those terms as well. So this may be a little confusing if you haven't seen a question like this before. But essentially, we need to find the points of intersection. So whenever we want to find points of intersection, we let two graphs equal each other, which means that 2ax squared is equal to 3mx plus b, which means that 0 equals negative 2ax squared plus 3mx plus b. Now, we want to find out when there are no points of intersection. So this is when we have to use the discriminant. So the discriminant is the section in the quadratic formula, where the quadratic formula is b squared, minus b plus minus b squared take 4ac over 2a. This section in here is called the discriminant, which is given by a triangle. So whenever we want to find out when there are no points of intersection, this value here under the square root has to be negative. And the reason why is if this value under here is negative, we can't have the negative of the square root, which means there's no solutions to this equation, which means there's no point of intersection. If we want one point of intersection, then this section under here needs to be 0. Because the square root of 0 is always 0 no matter what, and that will give one solution. If you want to have 2 points of intersection or 2 solutions, this needs to be greater than 0 because that would yield a positive and negative version of that square root. So for this question, we want no points of intersection, which means that the discriminant has to be less than 0 or negative, where the discriminant is b squared minus 4ac is less than 0. B is this little section here. So b is 3m squared minus 4 times a, which is negative 2a, times c, which is b. And all these numbers floating around may be a little confusing, but just try not to make an error because it is quite easy to. So we then end up getting 9m squared plus 8ab is less than 0. And we basically want to get it in the form a, basically get a by itself and try and find out what's going on this side. And the reason why is because this, to me, this looks like quite a unique solution, whereas these ones are quite sort of random. I would be testing to see if this works with either one of these first. So from here, we want to get a by itself. So we get 8ab is less than negative 9m squared. A is less than negative 9m squared over 8b, which gives us a is less than negative 9m squared over 8b, where b is greater than 0. And this is very, very difficult to explain. But basically, because b is greater than 0, this remains a negative. If this was less than 0, then this would be a positive. So that wouldn't actually satisfy the equation. But all we need to know is we've got a is less than negative 9m squared over 8b for 0 solutions or 0 points of intersection for these two graphs, which gives our answer b.